Welcome to Astronomy for All, the astronomy podcast developed by Space Club as part of its inclusive astronomy outreach program, delivered with Google Notebook LM. Episode 2. The Sounds of Space, Unheard Mysteries of the Cosmos.
Whoa, okay. Did you hear that just now, that sound? I mean, it was like this deep rumbling, like almost like if you can imagine, I don't know, the giant beast kind of sighing, way off in the distance. It's kind of creepy, actually gives you chills, doesn't it? And you know what that was? That was the Juno spacecraft entering Jupiter's atmosphere. Like they turned the data into sound.
Yeah, that's a pretty powerful example, isn't it?
Yeah.
It makes you realize that what we think about hearing in space, it's not really what it actually is.
Yeah.
Most people think space is silent. Yeah.
No, total vacuum, no air, so no sound waves the way we usually experience them. That's how we usually think about it. But you hear something like that, and, well, it kind of blows your mind a little, I guess, right?
Right. Exactly. So that's what we're going to dig into in this deep dive, how we can actually hear the universe, even though it's not really through our ears the way we're used to hearing things.
We're going to get into some pretty cool stuff.
Yeah.
So we'll be exploring the science behind it all, like how plasma waves work and this process called sonification. How do scientists take these events that are happening out there, in space, and make them into something we can actually hear? And we'll also touch on how people have always sort of imagined the sounds of space, even way before we had the technology to really listen. So we'll be looking at both the cutting-edge science and these older, kind of more philosophical ideas about space and sound.
Exactly. Bridging the gap between them.
So let's start with the real sounds, I guess you could call them.
Yeah.
You mentioned plasma waves. So when we hear that Juno rumble, what's actually being converted into sound?
Well, it all starts with the fact that while space is mostly a vacuum, it's not completely empty. There are charged particles out there called plasma, and they're constantly interacting with magnetic fields in all these crazy ways.
Okay, and so these interactions...
Yeah, so these interactions are what create electromagnetic waves, including radio waves. It's like invisible ripples moving through this giant ocean of charged particles.
So it's not sound waves in the way we usually think of them, right? It's more like light waves, but at a different frequency.
Exactly. That's a great way to think about it. And just like radio antennas here on Earth pick up radio broadcast spacecraft like Juno Voyager Parker Solar Probe, they all have antennas designed to detect these electromagnetic waves out in space.
So the spacecraft are picking up these waves, which we can't hear naturally. So how do scientists get from that to something like that Jupiter roar we heard?
That's where the magic of frequency scaling comes in. They take those electromagnetic signals, which are vibrating way too high or too low for our ears to pick up, and they shift them down into the audible range. Basically, they're translating the data into a sensory experience we can actually understand.
Oh, that's pretty cool. So that deep roar we heard from Juno, that was basically converting those plasma waves from Jupiter's magnetic field into a sound we can actually hear.
Precisely. It's like having a universal translator for cosmic signals.
And I think you mentioned some other strange sounds that they've discovered using this technique, right? What else have they found?
Oh, there are so many examples. There are these high-pitched whistles and chirps coming from auroras on Saturn. Like our northern lights here on Earth. They're caused by similar interactions between charged particles and the planet's magnetic field.
Oh, wow.
Yeah. And then Voyager 1, when it was traveling out of our solar system into interstellar space, it actually detected this kind of rising hum, probably from plasma oscillations in deep space.
Deep space hum. That's wild.
And even crazier scientists studying black holes have used the reverberations of X-rays to create these deep, almost droning sounds from the environment around the black hole.
Black hole drones. That sounds like something straight out of science fiction.
Doesn't it? It's amazing to think that these events happening millions of light years away in ways we can't even begin to imagine were creating these sonic signatures.
And these sounds aren't just cool noises, they actually have real scientific value, right?
Absolutely. By analyzing these converted audio signals, scientists can learn a lot about space weather patterns, the dynamics of planetary atmospheres, even map out the magnetic fields that are all over the cosmos.
Yeah.
It's essentially another way to interpret all the data that spacecraft are sending back to us.
Yeah, so it's like taking raw data and making it something our brains are really good at understanding, right? Like sound patterns, changes in rhythm and pitch. We're really good at picking up on those things.
Exactly. Our brains are wired for sound.
Now, I think you mentioned something earlier called sonification of astronomical data. Is that the same as converting plasma waves into sound?
Not exactly.
Oh.
While converting plasma waves is definitely a type of sonification itself is much broader. It's basically taking any kind of non-audible data and turning it into sound.
So, like, what kind of data are we talking about?
Oh, all sorts of things, like the intensity of light in astronomical images,
Yeah.
the timing of pulses from pulsars, those spinning neutron stars, or even the vibrations they've detected in spacetime around black holes.
Wow, so they're taking all this data and mapping it to different characteristics of sound, like pitch, loudness, rhythm.
Exactly. And it's not just for the sake of making cool sounds. It actually has several really important benefits.
Like what?
Well, for one thing, it can help with scientific discovery. Sometimes patterns in data that are hard to see in a graph or an image become much more obvious when you can hear them. It's like listening to a piece of music. You might not get all the details just by looking at the sheet music, but when you hear it played, you pick up on all these hidden structures and relationships.
That's a really interesting way to think about it. A change in pitch or rhythm would definitely grab your attention more than a subtle change in brightness in an image.
Right. It's about engaging different parts of our brains.
And I think you mentioned another benefit.
Yeah. Sonification is a huge step forward for accessibility. It allows people who are visually impaired to experience astronomical data in a whole new way. They can explore a nebula by listening to the sounds assigned to different regions, or track the changes in a star's brightness by listening to the corresponding changes in pitch.
That's amazing. It really opens up space exploration and scientific discovery to a whole new group of people.
It does. And then there's the public engagement aspect. Turning these vast and often abstract cosmic phenomena into soundscapes or even musical compositions can make space feel much more real and relatable for people.
I can definitely see that. Like when you hear a sonified image from the Hubble or the James Webb Space Telescope, where stars twinkle like high notes and clouds of gas make these deep drones, it really sparks your imagination in a way that a static image can't always do.
It's about making these events that seem so distant and incomprehensible suddenly feel much more real and immediate.
Like you're actually out there experiencing it.
Exactly. And it's interesting, because this whole idea of using sound to understand the cosmos, it's not new at all.
Oh, really?
Yeah, think about the ancient Greeks and their idea of the music of the spheres.
Oh, yeah, I remember learning about that. They believed that the planets and stars moved in perfect harmony, creating this divine music that was usually too faint for us to hear.
Right. It's amazing to think that even back then they had this intuition that the cosmos wasn't just silent and empty.
It's like they knew there had to be more to it than what they could see.
And that idea wasn't unique to the Greeks either.
Hmm.
And then there's the ancient Mayan civilization. They were deeply connected to celestial events, and they believed their gods communicated through sounds. Their priests even used these creepy death whistles that some researchers think were designed to mimic the sounds of certain celestial events, or maybe even the voices of their gods.
So whether it was the music of the spheres for the Greeks, the sacred iamb in Eastern traditions, or the cosmic whistles of the Mayans, there's this really long history of humans trying to understand and connect with the cosmos through sound.
Exactly. And what we're doing today with our technology, converting plasma waves into sounds we can hear and sonifying all this astronomical data, it's really a continuation of that same human impulse. We're still trying to make the cosmos more tangible, more understandable by experiencing it through sound just now with a much more scientific approach.
It's a fascinating connection between these ancient ideas and our modern capabilities, both driven by this same curiosity about space and this desire to connect with it on a deeper level.
And it all comes back to that sound we heard at the beginning, the sound of Juno entering Jupiter's magnetosphere. Throughout this deep dive, we've explored how that sound, and others like it, are made by turning phenomena that are naturally inaudible to us into something we can hear.
It's not just about cool sounds, although I have to admit they are pretty cool. It's about finding new ways to understand the universe, making space exploration more inclusive, and tapping into this ancient human intuition that the cosmos has a sonic dimension even if we can't hear it directly.
That's it for today's episode. Thank you for listening to Astronomy for All, the astronomy podcast created by Space Club as part of its inclusive astronomy outreach program. Space Club is the astronomy club of the Romanian Military Space Agency. You can get in touch with us on our Facebook page at spaceclub.astro or through our contact details published on www.spaceclub.ro.